Hello, we are discussing about GATE 2015 ECE paper. Look at the AC equivalent circuit shown. In that one, the two PJTs are in active region and have identical parameters, and their beta value is going to be given greater than 1. Find the open circuit small signal voltage gain. Okay. So first we will start. There are two transistors. One is NPN transistor. Say this is T1, and this is PNP transistor. According to the arrow direction is inside. So this is PNP transistor, and I am saying it as T2 transistor. Okay. T1. For T1, input is directly connected to base and emitter is grounded. Output is taken across collector. So this is acting as common emitter amplifier. We know for common emitter is common terminal, base is input, collector is output, which satisfies the requirement for T1. So T1 is acting as common emitter amplifier and T2 acts as load. And whenever T2 is acting as load, basically T2 is the active device that is now acting as a load. So this load is going to be treated as active load. In general, we will use a resistor for a load. By that time, that is called as passive load. If a load is implemented with active device, then it is called as active load. Okay. And if you observe, T2 is acting as a load, and for that T2, this is base and it is collector, this is emitter for the T2 transistor. So B2, C2 and E2. If you observe, base and collector both are going to be shorted. That is, both are connected at same node. So two of its T2 transistor terminals are shorted. Then this T2 acts as diode. So now the T2 is going to be equivalently as a diode, since collector and base are going to be shorted. Now the diode is going to be working in between emitter and base because only two terminals it has now. So there is a diode that can be replaced. That is, the T2 transistor can be replaced with diode. Okay, and voltage across diode is nothing but VBE. Okay, VBE2, voltage from base to emitter. VBE2, this is minus 0.7 volts around. Okay, for small signal, we will consider it as variations in VBE2, that is VBE2 itself. Next, for transistor T1, okay, for transistor T1 is also in active region. Active region means emitter base junction forward bias, collector base junction reverse bias. It has given both the transistors are in active region. Active region means emitter base junction forward bias and collector base junction reverse bias. So emitter base junction forward bias, this is base and it is emitter. So the voltage across this one is VBE1 and collector base junction is reverse bias. It doesn't matter for us. So VI is the voltage across base, that is equal to VBE1. So VI can be written as VBE1 first equation. V0 is voltage from this point to ground. So V0 is equal to voltage from V0 to ground. V0 to ground is nothing but you are moving in this direction. Okay. So this is minus 2 plus V0 is equal to minus VBE2. This is second equation. And voltage gain, small signal voltage gain is V0 divided by Vi, which is going to be VBE2 minus divided by VBE1. Okay. So VBE2, VBE1, since both are going to be identical devices and variations are also, we expect the same. So that it is going to be approximately equal to minus 1. So voltage gain of this one is equal to 1. The right answer for this one is 1. Okay. And if you are able to replace transistor T1 with R parameter model and this transistor T2 with a single resistor in forward bias, that is RF, then you may be getting confusion. There you may get a answer as beta, but by that time you will think that one RF is constant. If you think RF is constant in forward bias diode, then the answer will be equal to beta, okay, RF or R pi, that is the resistance in the forward bias diode. Resistance in the forward bias diode is not constant. As current increases, resistance reduces. As current increases, resistance reduces, or reversely, as current reduces, resistance increases. And the product is going to be, product is voltage across base to emitter is always constant. That base to emitter is nothing but V0 itself. And again you are going to write the voltage gain as V0 by V input. Both are VBE only, and the voltage gain is approximately 1 itself. Okay, don't confuse, the answer will not be beta, answer will be a unity. Okay, so the right answer for this question is 1.